Hello once again, this is Moria again, and today I learn about this strategy design pattern. As the name suggests, there are some strategies on which we apply this pattern. And what are these strategies? Suppose I have to perform some task on this, and there are various strategies to perform this task. Suppose this is one strategy. If I perform this strategy on this task will be completed. There is another strategy. If I apply this strategy on this task, then this task will be completed. There is another strategy. If I apply this strategy on this, then this task will be completed. So you can see I am saying that if this apply this, and then if we apply this strategy, then the task will be completed in their own ways. So there is some intuition of this if else statements, and there is multiple interchangeable algorithms. I apply this algorithm, then this algorithm, then this algorithm. These are the algorithms. So when I have an intuition for these things, I think of this strategy design pattern. Okay, let's understand this in a example. Suppose I have to design a navigation application which will be taking me from source to destination via some mode. That mode can be car, bus, or a train. So how will I do that? I will apply this navigation as and create a method build route, and it will build me route from the source to destination via a mode. And that mode can be car or a walk or a train or a bus or a truck or an aeroplane. And if I have to use it in my main class, what I will be doing? I will create the object nav, and then I will call this method nav.buildRoute that will take me from home to college via the bus. Okay, until then everything is fine. But what is the problem that this code might face? So let's understand or tackle the problems here. So you can see that there is some if else block. So this is the problem. If I have to add one another mode, I have to modify it. So it is violating the open close principle firstly. Secondly, let's suppose I have to go from here to here, and in the midway I think of that, okay, let's not go for the bus, let's take a cab from here and then go from car from here to here. So that is also not possible. So there is no dynamic switching also. Okay, so how to understand this? So let's find out a solution for that. We will apply various strategies. This car, walk, and these things are the strategies. So why not I create a class of strategies where I will be implementing these methods separately, and then in the build class of that nav build, I just call these strategies. Okay, so that can be executable. Let's execute it and think of in the code terms. So I have created a vehicle strategy class that has an interface and have build route method that will take me from source to destination. And these are the strategies. This will be implemented in their own ways. This will be implemented in its own ways, and this bus strategy will be implemented in its own way. Now here comes the navigation app class. What it will do? It will have a reference of this vehicle strategy so that my application knows which strategy I have to apply. And this is the thing that will be dynamically changing my strategy in the runtime. What it is? Set vehicle strategy, and it is taking the object. Which object? Vehicle strategy object. So it will set my strategy, and then there is a build route method that will be calling me the s.build route. S will be the reference of this vehicle strategy. So the strategy which I have applied while creating this nav app, that will be applied in here. Okay, so my problem will be solved. Yes, the problem will be solved. How? Let's understand it here. So I have two problems. There was open close principle. I have solved it using this logic, and there was a dynamic switching. I cannot dynamic switch at that time. So let's understand how that problem is solved here. So I have created a nav app, and in here I have applied the strategy in the runtime itself. So if I have to go from home to office, I will create this strategy, and this knows that I am applying this car strategy. Now in meantime, I switch to different strategy. Suppose I want to go to bus, then I will be doing. This is the method that will do my work. Set vehicle strategy. So it will set my vehicle strategy to the bus strategy. If I have to change it from bus to another one, I have to just call this set strategy method and it will be changed. Okay. And then I will build the route on its own. So in this way, I have solved both the problems. What were those? Open close principle, and that second one was no dynamic switching. So yeah, if I see some if else block or switch statement and there are various algorithms to do some a particular task, then I will think of this strategy design pattern. So let's formally define this pattern. And what does this pattern says is that this pattern let me define a family of algorithms. Family of algorithms. These are the family of algorithms, and each of them into a separate class. Okay, we have created a separate class and make their object interchangeable. And make their object interchangeable, it means I am dynamically switching this object from one to another, like this or this. So in this way, I can understand that what dynamic strategy design pattern is. So that's all from my side. Bye bye.